Okay, I welcome you, my dear young friends, for instrumentation and control systems for Unit 5. So, in this Unit 5, we are having control systems and different types of elements of control systems. And in this open loop control systems, closed loop control systems, and the differences of control systems, and operations of servo mechanisms, and examples of control systems, speed control systems, position control systems, temperature control system, open and closed positioning systems, and transfer functions, and block diagrams, different types of control systems like closed loop and open loop. So this is the content of our Unit 5 control systems. Now we will discuss what is that control system. So what is that control system? Control system is we are going to controlling speed, we are going to controlling pressure, we are going to controlling velocity, we are going to controlling temperature. So many are specific elements are there, those things we are going to controlling with the in which the that specific function output we are going to controlling by the input. Suppose output is coming in the temperature, you can say that mostly I am going to taking maximum boilers. Okay, boilers, or you can take internal combustion engines, or you can take external combustion engines, steam engines. So in that the heat is going to be releasing more. Suppose we require heat is 10 joules per second. So the heat is coming out 100 joules per second. So we want to reduce how much the external combustion engine is required, because of we are going to controlling by controlled by the input. So we are going to giving whatever you can say that energy, you can say that fuel, you can say that any coal, thermal energy, you can say that whatever it may be, that we are going to controlling by the input to output. That is called as control. Means the entire system we are going to controlling, that is called as control system. So there are so many control systems. Okay, now we can see that what is that control systems diagrams, how it will be there. See that control system will be there, input we are going to giving, it will be processed, and then it will come out, See that best example I am going to showing that speed of a car. So we are going to controlling by the speed of the car. How we are going to controlling? By doing that accelerator. So that is we are going to controlling speed of a car, means we are going to pressing that accelerator, and we are going to controlling the speed, means accelerator is going to be connected to that how much fuel is going to be supplied to that engine. So that over there we are going to processing it, and then the speed after processing the output will come. Okay, so now you see that electrical switches I am going to showing that in electrical switches what is going to be happening. So if you wherever in your rooms or bedrooms, whatever it may be, that so if you want light, you can we can switch on that light switch. So then the light will be blinked, means the light will be lightened. So over there we are going to getting light. So that is that controlled by that switch whenever we are going to switching over there, processing, and then output is light. So that is one more thing is there. I am going to showing that particularly on that washing machine. It's a very best example for control systems. See that in a washing machine, whenever you are going to putting that clothes, the washing machine will do that. We are going to giving some time. So in that time, suppose say that 10 minutes time you are going, 10 minutes time only it will do that washing, and after that it will going to be stop. Okay, so input we are going to giving time and processing it will do. After output it is a washed clothes it will give. Same thing, another one more example for this one is oven. So oven, if you want put your anything, say that bread or your bhaji, onion bhaji or potato bhaji, or else coffee or tea. So all these things we are going to keeping in our oven, or samosa. You are going to keeping in your oven, and some heat you are going to giving through the knob. So how much heat? Suppose if you want heat 10 degrees centigrade or 20 degrees centigrade or 30 degrees centigrade. So you are keeping that button whenever that item means that samosa is going to be heated up, and then we are going to removing and we are going to heating. So here that is that control process. Means here is that advantages will be there, disadvantages also will be there. Okay, so we are not going to depth. Now our subject here we are going to discussing that only for that whether we are going to controlling that one or not. So that we are controlling. Okay, so another one more best example for that. You are traveling on that road. You are traveling on that road. So signal lights will be there. Red light will be there, yellow light will be there, green light will be there. Some particular seconds only it will blink. After that it will be stopped. Means it is going to be closed. The red signal is going to be closes, yellow signal is going to be lightened up, or it is going to, suppose some duration only it will be there. Means process will be there. After process only, when we are going to giving red light signal, some process will be there, that is called as time, and output will be there. Some of the vehicles is going to be passing on that. Some of the vehicles is going to be passing on that. So no problem. So this is called as control systems. First we are going to giving input, after that it is going to be process it, and after that it is going to be, we are going to be getting output, means result. Okay. Now we will see that next slide. So what are the types of control systems? There are different types of control systems is there. Before that we are going to see that what is that we are going to using, where we are going to using that control systems. Generally wide range applications of control systems means machine tool control we are going to using, satellites, whatever we are going to using, aircrafts control, and automatic and assembly line, quality of control of manufactured of components, transport systems, computer control, robotic control, and domestic systems means temperature, humidity. Okay, and the control of home appliances like washing machines, what I discussed earlier, and rice cookers, pressure cookers. Okay, all these things. And we are going to using digital computers also we are going to controlling, so that we are going to using that integral part of control systems. That's the recent applications of the control theory, non-engineering systems also, such as what is that non-engineering, biological, biomedical, economic and socio-economic systems also we are going to implementing these control systems. So in this control systems we are having some important terminologies are there. What is that terminology? First one is control variable and manipulated variable, plants, processes, systems, disturbances, and feedback control systems. These are the terminologies when we are going to using these control systems. So over there, here control systems are two types. One is open loop control systems, means there is no feedback. Open loop control systems, there is no feedback. So in our see that open loop control system, you can see that and another one more thing is closed loop feedback control systems. Closed loop feedback control systems. Now we will discuss one by one. We will see that. So open loop control systems, see that I am going to showing that figure. So input we are going to giving. Input we are going to, sorry, we will discuss first open loop control systems. Okay, so first this is the input we are going to giving. Okay, input, after that controller will be there. This controls the signal, and that control signal we are going to sending to the actuating signal to the plant, whatever it may be that, and output. So output it is going to be coming. So this generally open loop control systems best example is washing machine. Okay, washing machine does not know whether that cloth is dried or not. It doesn't know that. That is called as without feedback. So the machine will not see that. And best example for open loop control systems for signals. So one of the vehicle will be there in the last end and it is also crossing, but it won't see that whether we have to give that yellow signal or green signal or red signal. It never see that, but according to time factor it will work. So that is there is no feedback. That's why it is called as open loop control systems. Advantages will be there. It is very simple and it is very easier to construct and stable systems. And disadvantages also will be there. Disadvantages, main inaccurate. I told that washing machine example I told that, as well as this one also I told that. What is that? Signals. So these two are the best examples for open loop control systems. Next we will see that closed loop control systems. It will give that pakka feedback. So then it is called as closed loop control systems. See that advantages will be there. So how it will be there working, I will tell you. By seeing of this figure we can understand. Input we are going to giving. So any error will be there, it will detect. Okay, and a error signal, okay, after error it is going to the controller, and in controller it is going to be processed, and after that only we are going to giving the actuating signal to the plant, which work it has to be done. So and after that output, it will go for output. So here this in that output feedback element. So how output will be there, we are going to taking the feedback signal to the error detector. If the error will be there, it will detect and then it will send to that signal to the controller to the plant. So then we will get it output. Then only we can get it output signal. Okay, in this we can see that stability, we can see that. Okay, so positive feedback and negative feedbacks will be there. The data fed to be input, it will the same direction facilitate accurate input. Negative feedback, the data fed input to positive of the input. Okay, so next class we will discuss another differences and all the things. Thank you.